Hey guys, Mr. Huber here. Trying to go over some of these parametric and vector value functions, like how would you see them in an AP question. So this was from College Board, okay, and here you could see like the student programs a robot to move across a flat surface, and they're giving you like his movement with the X and with our Y coordinate, kind of telling us how it's moving throughout. Plus it also gives you the derivative of X and the derivative of Y, which is important here. Now this is a calculator question, so we could use the calculator in this stuff, but in my opinion, this is a great question because it goes through the parametric and the things that you need to know that they're going to put on the test. Now because this could be a free response that you see. Now writing the equation of a tangent line, what are the two things you need? Okay, so the two things that we need all the time is a point, right? And you need the slope. Okay, so those are the two things that you want anytime you're doing the equation of the tangent line. So in this situation, at time equals 4 seconds. So remember, t, when you're plugging it into both the X and Y, it's giving you your coordinate. So here, X of 4, I'm going to just plug it in here, 3 times 4 plus sine 4. All right, and it's giving me a decimal of 11.243198. So that is your X coordinate. And then do the same thing with the Y. So I'm plugging it into here, right? So I have 3 cosine 4 minus sine 4. And that's going to give me a 0.133197. Okay, so now when you do your slope, so we have the point right now, our point is going to be 11.243198, comma 0.133197. So that's the point that we have. All right, now finding the slope. So we go back to what you need from derivatives. Derivatives will give us slope, and we know in parametric dy over dx is going to equal dy over dt divided by dx over dt. So in this situation, we need to have this at 4. So again, not that difficult with the calculator, since you have x prime and y prime. So that's x prime is the same thing as dy dt. Y prime, my bad, that wouldn't make sense. Okay, x prime is dx dt. Y prime is dy dt. So if I'm going to look for this at 4, I'm going to do, you want this at t equals 4, I'm going to do y prime at 4 over x prime at 4. When I do that, right, you're just really plugging into these two. So let's see, y prime's a negative 3 sine 4 minus sine 4 all over. I'll plug it into the x prime, and I get 3 plus cosine 4. When I did that, I got 2.11228, and then that's our slope. So we have our slope, we have our point, and now point slope. Y minus 0.133197 is going to equal our slope, 2.112228, and x minus our x coordinate, and that would be your equation of the tangent line. So the things they are going to give you points for, you would get a point. This is only a 2-point question, so you would get a point for 1 point for the slope and 1 point for the equation. All right, now let's go over speed. Okay, so to find speed, we are doing basically it's a Pythagorean theorem. I'll probably do another lesson on this as well, but when you're looking for speed, you're really doing, how can I say this? The derivatives, and then you're taking a square root. So what it'll look like, so we're looking for the speed at 10. So again, with the calculator, you would get x prime of 10 squared plus y prime of 10 squared. So I'm just going to plug into the derivatives that were given right here, and I would get 3 plus cosine 10 squared plus negative 3 sine 10 minus sine 10, and then 1 minus cosine 10 squared. Yeah, the whole thing squared. So when I type that in the calculator, I get 5.414 and then 163. So at t equals 10, the speed is 5.414 meters per second. And on this one, you would get points for only 1 point. So again, it's like, if you're not sure about how to find speed of parametric, really formula would just be here. And I'm going to go back and do another lesson on speed because I forgot to do that, even though I spoke about it briefly when we were doing vectors, but not much, so I got to go back to that one. Okay, now we're looking for acceleration. So acceleration, remember, that's your second derivative, d squared y over dx squared. Probably one of the more important parts here, and actually, no, you don't even have to do that because we're just looking for the acceleration vector. So you don't need this, so I messed up that one. But because they're asking for the acceleration vector, you're just doing the second derivative. Okay, so it's really not that difficult because in this one you want to use the calculator. So you're kind of looking for f. My bad. Yeah, you're looking for x double prime so for here I want to find acceleration is going to be x double prime of t comma y double prime of t. And the reason why we don't have to really worry about doing much more than that is because they're asking for the vector itself. If they said for the acceleration, that would be different. But acceleration vector, you're just doing the second derivative and of both x and y coordinates. Okay, so now the other thing that they're saying is they need to find, you have to find out what time is because they're only giving you the x coordinate. So you need to set x of t in your calculator to 50. So make this y1, make this y2, and then see where the intersection would be, and that came out to 16.8 0.985798. Once you find that time, then you could use the calculator with the second derivative. So you're doing x double prime of this number, 16.985798, and that'll give you approximately 0.957. And you do the same thing in the calculator with the second derivative of y of that number, and that gives you approximately negative 5.334. So your acceleration vector a of t is going to equal 0.957 comma negative 5.333. Okay, or 334. Either answer will be okay. All right, and on this one you could get 3 points. Let's see. So you got to get a point for this value here. So finding that value gives you a point. X and Y components all give you points. So that is a point, that is a point. All right. And the last one we have is what's the average speed of the robot between t equals 0 to t equals 20. All right, so average speed. So because speed, if you go back, we kind of did this over here. Whenever you're doing average of something, you're dividing it or multiplying it by 1 over the distance. So here you're going to get 1 over 20, and then 0 to 20, you do the integral, average speed, integral of that speed function that we have, like this, squared plus y prime of t squared dt. You have to use the calculator on this one, plug that into the calculator, and you wind up getting 3.9969997, okay? And that would be, so I would say like 3.997 meters per second is the average speed between t equals 0 and t equals 20. All right, on this one, point values are going to be, I think you get 3 points here. So the integral setup gives you a point. The limits of integration and the constant, so that's all 1 point, and your answer is 1 point. Okay, so recap a little bit, right? Maybe just break this up a little bit better for you. Here's here's A. B, C, right, so A, B, C, and D. All right.